Hey everyone, so today we are talking about nonlinear motion. So far, in our exploration of motion graphs, we've only talked about linear motion. So creating straight lines with our graph. And we have been able to describe that, as we're going to talk about later on in the video. We've been able to describe linear motion as moving at a steady rate. So what if we don't want to move at a steady rate? Sometimes in the real world, we don't want to always be going 5 miles per hour. Sometimes we want to create a curve, or maybe we need to speed up or slow down as we come to a stop sign. So we're going to explore what these motion graphs look like in terms of the kinds of movements that you would have to do to make them. So as you can see, we have Terrence here, and we are going to try to match his graph. If I start him at the starting position of 6.5, I can see that on my y-axis, I know this is my starting position because I'm at time 0, and I'm about a quarter of the way up between the two digits. So 6, 6.5, 7 would be right in the middle, 7.5, and 8. So I know I start at 6.5. And then if I were to move Terrence at a steady rate and just bring him towards his motion detector, we see that we get a straight line. But we clearly see that the line that we're trying to make doesn't match, okay? So we have to think, sometimes I think of it in terms of chunks. So the first 2 seconds, I have very little change in my rate. It's almost flat. And we know that a flat line is when we're standing still. So it's not quite a straight line. So we know we're moving a little bit, but we're going very slowly. And then if we chunk it into the next segment, our line starts to get just a little bit steeper, and it continues that for the rest of his ride. So we know that a steeper line means a faster rate. So if each segment or second we're going just a little bit faster, we should be able to check or to match our graph. So let's start in the right space. We're going to start out very slowly. Oop, I started going too fast. And as we go, we're going to get faster and faster and faster. So we all know that matching Terrence's line perfectly is really hard, but we started out super slow. We went a little bit faster over and over. So when you see a curve on a motion graph, you should know I'm accelerating, I'm going faster, or I'm going slower. So that was an example of going faster. We started out very slow, and by the end, we were going faster. Let's see what happens if we start out fast and then end slow. So same starting position. Now we're going to start out faster, and then we're gonna slow way down till we're almost not moving. Okay, so that was an okay one. Obviously, I need to go even faster at the beginning. So within the first second, I need to go from 6.5 to almost 4. So if this is 6, 5, 4. All right, let's try it one more time just to see if we can get there. And then we slow way down. I still didn't do that beginning part very well, but you can see. If we wanted to make a really clear graph, we're going to try that in just a moment. But let's jump to your activity book. If you're following along in your activity book, you should be on page 292. So we're going to take just a few minutes, and we're going to describe how you would make each of these graphs. So here we start out very slow and then it seems like we speed up. Let's see if we can do that with Terrence. So it looks like we start just a little bit away from the motion detector. So maybe here. And we're gonna start out slow and then we're gonna really go to the top. That wasn't very good. Let's try it one more time. I'm gonna start even further. So we can start out super, super slow and then get faster and faster and faster. And so we can see this nice curve that happens. So on your activity book to write a description, we could say we would start out very slow and then speed up from there, okay? So we could, if we had times marked on here, we could tell the different time segments, but just where we're at, we started slow, we sped up until we were going very quickly. Now, we could say, one thing that we could add, let me add it to it, start up slow and then speed up as you move away from the motion detector. Okay, the second one here, we should already be able to do it. So think to yourself before, or maybe pause the video and write your own description and then check it. So here we are, start a few feet away from the motion detector, then move away from the motion detector at a steady rate. Okay, we could even say at a moderate steady rate. I mean, without distances and times marked on our axes, we don't really know. So we can check this really quickly using Terrence. So for Terrence to move at a steady rate, we want him to start a few feet away and we're going to move at a steady rate away from the motion detector. So you can see when we move at a constant rate, we get that straight line. Okay, let's reset and go back to our book. So for C, let's do C and D. I'm going to erase these. For C and D, so here for C, we have three lines, but they're all straight lines. So thinking about talking about linear motion versus nonlinear motion, remember that linear is always a straight line. So these are linear lines, they make lines, and we know to make those, we need to move at a steady rate. So again, I want you to think about what this is, maybe go into Agile Mind and try Terrence out yourself, but your description should be something like start at 8 feet or even maybe a little less, 7 feet from the motion detector, move at a steady rate towards the motion detector, then at about 2 feet, stand still, no moving, stand still for a few seconds, then move away from the motion detector at about the same steady rate. Okay, so kind of a long description, but we've been working to add those details in. All right, so for part D, we see this curve. We don't have a straight line anymore. So we know that this one should be similar to our descriptions that we talked about at the beginning with these two motion graphs and this motion graph. So almost think to yourself, look, this looks like the second half of our graph. We get that same curve. So to make this part of the curve, we talked about you had to speed up, okay, moving away from the motion detector. And in this graph, this looks like the first half of that curve. And so we started out fast and then slowed down. So to write our description for this, I want you to practice it first, pause the video, write out your answer, and then unpause to see if you got it correct. So we want to start about 6 feet from the motion detector, move quickly towards the motion detector, but slow down as you get to about 2 feet. Then speed up as you move away from the motion detector. Okay, so that's my answer, is that we're going to start out fast, we're going to slow down moving towards, and then we're going to speed up moving away. So let's check our answer really quickly by going back to Terrence. And so let's see if we can do that. We're going to start at this end. Okay, I'm actually going to start him at 7 feet. So we're going to go slow, and then we're going to speed up going back up. Okay, so I didn't really get the curve, but I definitely got the go towards the motion detector and away. So let's see if I can do it better this time. We're going to use the whole graph. So we're going to start out quickly, and then we're going to slow way down. Then we're going to go slow and then go fast. Oh, okay. So not perfect, but we did use the correct motion. So we started out quickly, our rate was high, and then we slowed down, changed direction, still moving slowly, and then sped up as we ended our graph. So kind of key things about motion graphs that we have talked about in this lesson. We talked about linear versus nonlinear. So this is linear. It's made up of lines, 3 straight lines. And then we have nonlinear, which means that we have a curve to our graph. Okay, so if we had to kind of label different parts of this, we would say the steep part is faster, and the flatter parts, I don't know if flatter is a word, but we're going to use it. The parts that are more flat are slower. Okay, so kind of key things to think about as you're asked to describe the motion. So your assignment today will have a couple of these graphs on here. I want you to use the slides in Agile Mind. If you need it, you can use any of the lessons from topic 7. They all have a slide with a blank Terrence screen on it that you can use. All right, that's it. Give it a try, and we will meet together this week to talk more about motion.